Hey, ninth graders. All right, we are on page 101 and we are talking about interpreting functions. At the very top of this paper, it says, given the graph of f of x, answer the questions below. So we have this graph f of x, and the first question is asking, what is f of 2? Now, this is sort of like that day where we talked about using functions. We were given an input of 2. So if the input is 2, that is an x value. And we want to find the output, which will be a y value. So I'm going to go to my graph, and I'm going to find 2 on the x-axis. Now I need to find where 2 leads us to in this graph. So I have to count up until I reach this spot right here. That is going to be up 1, 2, 3, 4, 5, 6. So that when I know that x is 2, the y value is 6. And I could write my answer as just f of 2 equals 6, which is how it's going to be typed in on your homework and on your tests and such. The input is 2 and the output is 6. It's also like the ordered pair 2, 6. Okay, let's look at the next one. For what values, if any, does f of x equal 3? So our job this time is to see if there are any places on the graph where an output is 3. So I'm actually going to find 3 on my graph, and I am going to draw a dashed line where it is up 3 spaces. That was not a great dashed line because you couldn't really see exactly where it was. So I'm going to make it a little bit darker. Okay, where is our graph equal to 3 as an output? Well, there's only one place. It's right there on the graph. So what input gave us that output? Well, something that might be helpful there is that ordered pair is 0, 3. It's the only ordered pair on this black line that would have a 3 in the y value. So what's the input that will give you an output of 3? Well, the input is 0. 0 is the thing that I have to input. So I would say x equals 0. That's the only input that goes up 3 spaces on the graph. All right, now if there were multiple, that'd be great. We'd have to have multiple of them, but there are not, so we're okay on this one. All right, so what is the x-intercept? Now remember, that's where the graph crosses the x-axis. Now I know my x-axis goes to the left and right. This is my x-axis, and this one is my y-axis. So where does the graph cross the x-axis? Right here. And that ordered pair would be to the left 2, up 0. So to write that x-intercept, I would say to the left 2, up 0, -2, 0. Now, the next question, what is the domain of f of x? That means how far does this graph go to the left, and then how far does this graph go to the right? So let's look at this thing. I can see that the furthest left point on this graph is right here, and that is a filled in dot. So I am going to say that my domain starts to the far left at that place. How far to the left is that? 1, 2, 3, 4 to the left. Now, since it's a solid dot, I need to use a closed bracket. And I would say -4 is the furthest to the left that my graph can go. Now, how far does my graph go to the right? This dot is the furthest right on this entire graph, and that is at positive 1, 2, 3, 4, 5, 6. I wasn't really great at drawing my line, but you can see it's right there at positive 6. So I go from -4 all the way to the right where positive 6 is. And since that's a filled in circle, we use a solid bracket. Okay, let's look at another one. Let's look at where it says, on what interval is f of x bigger than 0? We haven't seen a lot of them where they have less than, greater than stuff. So greater than 0, where is the graph greater than 0? So I'm looking at this graph and I can see that 0, x equals 0 is this line right here. So it's saying, when is the graph bigger than 0? Well, everything above that line is bigger than 0. But I wouldn't say that the entire graph is above the line. I'd have to say, where does the graph start being above that line? And where does it end being above that line? So what would be my interval for being greater than 0? Well, it starts being greater than 0 right here. And then we can start splitting hairs. We can ask, is it a solid dot there? Is 0 bigger than 0? I don't know, probably not. So I guess maybe we shouldn't do a bracket. Maybe we should do a parenthesis. I'm not going to be that picky on your test, but I just want you to know that, yes, technically we could do a open parenthesis because it's at 0 at that point. But where does it stop being bigger than 0? Well, it goes all the way to the end of the graph, all the way over here. So we would say it starts at -2 and it ends being above 0 to the right 6 spaces. Again, if you wanted to put a hard parenthesis -2, I would be okay with that. I just know that if I don't put a soft parenthesis, I'll have a couple of you email me saying, Mrs. Johnson, 0 is not bigger than 0. You cannot include the point -2, which is correct. Okay, so let's look at another problem. Let's look at problem number 6. On what interval is the graph f of x increasing? Now we know what increasing means. That would mean that the graph is going uphill. So where is this graph when we're going left to right headed uphill? All of it. All of it is headed uphill. So we're actually going to steal our answer from the domain because the entire thing goes uphill. It is from -4 to +6. So I'm going to say -4 to +6. Problem number 7 says, on what interval is f of x decreasing? Well, where is it decreasing? Where does the graph go downhill? No, we can't talk about it backwards. We can't say from 6 to -4 because the graphs always go left to right. We have to be able to talk from the left number to a right number. So there's nowhere that this graph is decreasing. We have a symbol for that. It is a circle with a dash through it. That is the empty set. It just means nothing or none. Okay, when is f of x greater than 3? F of x greater than 3. All right, I'm going to go, remember how we drew a line at 3? That was pretty handy. We now need to look at any of the dots above that line. So all of that green section. Well, where does it begin going above 3? Right here. Ooh, I did it again. I should probably do an open parenthesis. And where does it stop being above 3? All the way at the end here. So we would say from 0 to 6. I'm going to do the open parenthesis again, just to remind you that technically 3 is not above 3. If it had an equal to symbol, that'd be great, but it doesn't. Okay, I want you to take a stab at the next 1, 2, 3, 4, 5, 6 problems. Push pause, try those. Let's see how you do, and we're going to discuss them once you're all done. I know they're different. I know they're difficult. You got this. Try them out. Okay, if we look at these, it says consider the linear graph, which is f of t, the straight line, and the nonlinear graph, g of t, and you're going to answer questions 9 through 14. Approximations are appropriate here because sometimes you're going to have to approximate where something is. So it asks us when or where does f of t equal g of t? So ninth graders, when do the two graphs equal one another? There are only two places where that happens. One of them is right here, the other right here. And those two places are -2, -1, and to the right 1, 2, 3, up 4. So -2, -1, and 3, 4. Next question. Where is f of t greater than g of t? So it's asking, when is the straight line above the curved line? Some of you might be thinking never because the curved line is above. But really, if we look, let's follow where this highlighter is. Right now, g of t is above f of t over here on the left. And it's still above, still above, still above. But when they touch the same point, g of t is not above. They're actually at the same exact place. And in this section in the middle, do you see how the straight line is on top of the curved line? So all of this section in the middle has f of t above g of t. And then when we hit this part over here, you can see that the curved line spikes back up and goes above the straight line. So what section is the straight line above the curved line? Well, it starts right here. It starts there and it ends there. And that would be from -2 to 1, 2, 3, +3. So I'm going to say -2 to 3. And I'm putting those soft parentheses on there because when they're equal, one of them's not above the other. So we'll just talk about from that section to that section, but included inside those soft parentheses. Okay, what is f of 0 plus g of 0? Let's find where 0 is. If I find f of 0, it is this dot right here. That is up one space. So I'm going to call that a 1. F of 0 is a 1. Then g of 0, well, I have to go down to -5. Down 5 spaces. So f of 0 is 1. G of 0 is -5. And when I add those together, I get -4. And that's my final answer. Pretty crazy. Not really that crazy, actually. Okay, on the next one, what is f of -1 plus g of -1? Well, at -1, f, the straight line, is at 0. And g, the curved line, at -1 goes down 1, 2, 3, 4. So I would say -4. When I add those together, I get -4. Fancy that, we get -4 twice. Okay, what is greater, f of 0 or g of -3? Well, I already found that f of 0 is at +1. G of -3 is 1, 2, 3. It is all the way up here, which is approximately at 3, I think. Oh no, I think I'm actually wrong. I think it's up here at 4. Just cover that up. Which one's bigger? Well, the second one's bigger. So I would say g of -3. Okay, last one. What is f of 0 minus g of -4? I've done this one a couple times. I know f of 0 is 1. G of -4 is right here, and that goes up to approximately, oh, it's all the way up there. Oh my goodness. It's hard to see on this paper. All the way to the top at +11. So I'm doing 1 minus 11, which is equal to -10. All right, that was your practice for today. We're going to do the back side of it for tomorrow's notes.